how much time everything takes. These are new notes. I believe I handed it out to the people who were here yesterday. If you did not get the notes or if you don't know where to find them, if you go from my homepage, if you go into, hopefully you know this already, anytime you need notes, if you go into modules and click on wherever the current chapter is, then it should have my videos. It should have, you want the blank copies of the notes. When I'm done is when I post these. So if you don't have them yet, go into modules, click on wherever the current chapter is, and that should be where you can find it. This section is going to be about different types of graphs you can make with quantitative data. So in the first section, we looked at graphs with categorical data, like bar charts and pie charts and two-way tables. This is going to be all about quantitative data. So numerical data, where we might be looking for what's the average amount of something. So there are three main types of graphs that we're going to look at today, and then we'll look at some more next week. But overall goal is going to be able to analyze this data and try and get a good visual of the numbers that we're looking at. The first type of these type of data is called a dot plot. And it's called that because the main thing we use to show the places that we're looking at is dots. So that means each dot is going to be a data point. So here's someone just short of 58. Here's someone just above 50, between 59 and 60. Here's two more. And if you have multiple bits of data, you can stack them on top of each other. You'll notice that one of the things we can say is that the bulk of the data is between 64 and 66 inches. Height and weight are good examples of quantitative variables. So we're going to be looking at them a lot. So each dot is a data point. So there should be 50 dots here for the 50 students. Let's look at one more example with a dot plot. So we have, don't forget, we have the x-axis labeled and we have the y-axis labeled. On a dot plot, where the y-axis is going to be counts, amount of something. X-axis here is number of matches per box. And something that you should think about is what's the goal that this data is trying to measure. For example, my guess is that the story that this graph tells is that there are probably, these are probably manufacturers of boxes that are supposed to have 50 matches in them. So we can talk about how close are they to that goal. And we can say, you might be thinking about what things you can tell me about the dot plot. And so I might ask about that in class on Monday and Tuesday. So bring to me ideas that you have. What things can we talk about, or what conclusions can we make about this dot plot? But hopefully you should be able to read it and say that each dot is an individual. For example, how many matchboxes are we measuring here? My count is 20. One for each dot. Each dot is a count. And remember the area principle, which is that these heights should reflect the amount of people that we're getting. You'll notice that The 49 that has 4 in it is twice as tall as these two that only have 2 in it. That's part of the idea of the area principle that we talked about earlier this week. Okay. That's a dot plot. Each dot is a person. The next one is a stem plot, and hopefully you're used to seeing some of these. It's also called a stem and leaf plot. A stem and leaf plot is kind of similar to a dot plot, except instead of categorizing each person as a dot, we're categorizing each person or data point instead as a number, as a single digit. And we're using that single digit to help narrow down where the bulk of the data is. So again, the goal is that you get an idea of where the data is centered at and what its shape is and how spread out it is by looking at the data. That's what we want our visuals to do. We want it to be, we want some of those features to jump out at us more than just a list of numbers would do. So here's your list of numbers, and here's the stem plot to go with it. Some things that should happen with a stem plot. The numbers on the left are called stems, and the numbers on the right are called leaves. That's why it's called a stem and leaf plot. And the numbers on the right side should be single digits, usually units. And you should include a key that has units in it. That's one of the more important things with the stem plots. So you'll see that we're showing that the 14 row, the digit of 7, corresponds to someone being 147 pounds. So that key will help us read the table and say, how big are we talking here? Are we talking about someone being 147? Are we talking about someone being 14.7 pounds? 1.47 pounds? 14,700 pounds? It matters. Make sure you include the key. So usually the stems are the rest of the digits in the number, and the leaves are the last digit. Not always, but most of the time. Leaves should be single digits. We want it to be in a similar way that the dots represented a person. We wanted each digit to represent a person. So this 0, 2, and 9, that's not 13,029. That is someone has 130, someone is 132 pounds, someone is 139 pounds. You can see that in the data. That's these three numbers put out as digits. So you can see that there's 3 numbers in the 130. Leaves should be in numerical order. That just makes it easier to read. It's very similar to the idea of a dot plot. Instead of a dot representing a person, a digit represents a person. Now, there are a few things that we can do to a stem plot to illuminate or visualize the data better. One of the things you can do is you can have back-to-back stem plots. So let's say that you have 2 different sets of data that you want to directly compare. So here are the male weights that we had earlier. And here are some female weights. And we want to make a comparison between what are any differences or similarities that we see between the male weights and the female weights. So if we're looking to do that, what we can do is off on the left side, we can have another set of data that is female. That's why it's called back-to-back, because they're directly in a row with the stems at the center. All right, close enough. Now, if you have 2 numbers, if you have 113 and 113, you're going to put it twice. Because again, we want each digit to correspond to a person. We want that visual idea of, oh, there's two people that weigh 113 pounds in this data. And again, it might help us to get that visual of what the data looks like and be able to talk about it and discuss it. What are the comparisons between the female weights and the male weights? Those are your questions to think about. All right. Next. Some more things we can do with our stems. Let's talk about different types of data and how spread out it is and what that's going to mean for our stem plots. When a data set is very compact, it's also useful to repeat stems to stretch out the data. This is sometimes called a split stem plot. So let me give you a visual idea of what we're talking about. If I were to make this chart of body temperatures, then what we would have is, let's see, we've got 96, 97, 98, and 99. And over for the leaves, we have 96, 97, 98, and 99. Over on the leaves, we could have 96.3, 97.6, 0.8, 0.9, 0.1, 0.1. And the problem with this data is that it's extremely crammed together to where you lose some of the nuance with where are the lower bits of the data and where are the higher bits of the data. You can see that it's very drawn together, but it's not very easy to tell around where the center is. And so what we might do is we might split it up. Usually in any of these visualizations, 5 to 10 groups is a good number to aim for. So since this only has 4 groups, it's really hard to see, okay, within the 98, what's going on. There's a lot of them, but where are most of them at? So what we can do is instead we can have the first half of 96, the second half of 96, and then the first half of 97, and the second half of 97, the first half of 98, and the second half of 98, the first half of 99, the second half of 99. And don't forget, you want the first half to be, you want 5 digits in the first half. So the first half is going to have 0, 1, 2, 3, 4. There's 5 digits. 0 through 4 in the first half, 5, 6, 7, 8, 9. That's 5 digits. 5 through 9 is going to go in the second half. So the lower half is going to have 0 through 4, not 0 through 5. So 96.3, that goes in the first half. 97, we have nothing in 0 through 4. 97.6 goes in the first half. Or goes in the second half. Excuse me. 8, 9. Anything 0 through 4 goes in the first half of 98. Anything 5 through 9 goes in the second half. So 5, 6, 6, 7, 8. And again, what this is helping with is it's helping you to see where some of the visuals are. And you can see that this 96.3 up here is a pretty low data value. Of course, we want a key. This time, This time, 9-6 with a 3 at the end is not corresponding with 963 degrees, it is 96.3 degrees Fahrenheit. All right. So that is split stem plots. Allows us to spread out the data a little more to be able to give some visuals. Let's look at another way to split up the data. All right. We probably don't want to split this stem plot. We'll talk about what truncating means in just a second. But let's say I wanted to make this data. And we said that usually we have here's the key. $105 and 3 corresponds with $10.53. Okay. So there's 105.3. And now we want to make 106 and 107 and 108 and 109. I hope you're spotting the problem. Otherwise, you must have a longer piece of paper than I think you do. This is way too much. Think about how far we'd have to go down. I'm not even $11 yet. This is no good. So what we're going to do is we're going to truncate the data. Truncate is basically cut off the data. That's another way to say it. And so what we're going to do instead is instead of having the very last digit on there, we're going to cut off that very last digit so that the data can be a bit more compact. We have the opposite problem that we had last time, where the data was too tightly packed together. This time the data is way too spread out to do it the way we were doing it before. This is the opposite problem we were having before. So instead of doing that, we're going to have it stand for $10 and then $11 and then $12 and $13, $14, $15. And now it looks a little bit nicer. We have 10, 50. We have 13, 60. Truncate is the opposite of rounding. It literally means cut the digit off. So slice off the 3, slice off the 7. We're not rounding up or down. That's what truncate means. It's kind of the opposite of rounding. Then we have 1501, so 15 and 0 is our digit. So it looks good so far. Here's the problem. We got to go all the way to 52. This is still not going to work. Let's start over. We're going to have to truncate it off even more. I'm slicing off the last 2 digits. The only digit that's going to go in the stem is 1. Then 2, then 3, then 4, then 5. And now it's much better to make the stem plot. Key. 2, 5 corresponds to $25. And now we can make it. I've got a $10 purchase. I've got a $13 purchase, a $15 purchase, 18, 20, 20, 27, 32, 37, 52. It's all about creating the nicest visual for what is the data that we're looking at. If we were in class, I always enjoy having people make this stem plot and starting with the 105 and 106 and then just telling people to keep going and say, no, keep going. You have to do it. But I was not able to do that this year. Oops. All right. That should be everything with stem plots. All right, we'll talk about this on Monday and Tuesday. I think I have time to talk about histograms. Let's do it. And then I'll have an assignment for you about them in class when we get back in class on Monday and Tuesday. Yeah, it shouldn't take too long. I can at least introduce histograms, and then we'll talk more about them as we go here. All right. Dot plots are very good for displaying small data sets, but when there are a large number of observations, histograms are a better choice. So they look a lot like bar charts, but they're bar charts for quantitative data. And what we do is we split them off into ranges. So instead of having 30 data points between 150 and 200 and having to put a dot for every single one, that's a whole lot. Instead, what we can do, because we would have about 100 dots to place here. Instead, what we can do is we can just have a bar that represents the 30 people. And so if we have between 100 and 150, we can read it and say, okay, we have about 4 or 5 trees between 100 and 150 centimeters. And then we have about 30 in between 150 and 200 centimeters. We have about 200 and 250. We have about 25 of those. Between 250 and 300, we've got about 50 of those. Between 300 and 350, we've got about 10. So we pick data ranges to go on. We pick a scale of data ranges. Again, aiming for about 5 to 10 different data ranges. I think it says 4 to 10 down here. That's fine. You want to pick some nice data ranges to go on. And from there, just scale your bars. The main difference to be able to tell that it's a histogram is, first of all, it should be quantitative data. So you should have numbers down here. And the other way you can tell it's a histogram is that a bar chart has the bars separated from each other. So you can see that they're in separate categories. The histogram has the data combined together. There's no separation between the bars in a histogram. Here's between 100 and 150, and it goes right into 150 to 200. So the bars should be, the bars should touch so that there's no leaving out any possible values. Make sure you label the axes. Make sure you label, make sure your vertical axis starts at 0. And the bars should touch. And so we'll look at some more examples with and talk about ways that we can analyze data on Monday and Tuesday. And we'll also, on Monday and Tuesday, we're also going to look at our first AP free response question. So we'll talk about how we can write about and analyze data, and